So, resolve this one into its vertical and horizontal components then. A very common thing to have to do so this force, 6 newtons, we've got to resolve it into its vertical and horizontal components. First off, there's 2 conventions to consider. The first convention is about angles. That doesn't apply in this case because the angle's given to us 40 degrees. But remember, normally if I were to quote the angle for this force, it wouldn't be 40 degrees. It would either be 180 plus 40, which is 220 degrees, because we always measure angles anticlockwise from the positive x-axis, or I could say it's negative 180 minus 40 degrees, which is 140. But so I've actually given you a bit of a help on this one by giving you the angle that you're going to use in the question, but that's not always given. The other convention that's important to remember is this one here. And that's up to you what you set. So you set that convention. If you're doing problems like this, you need to put something in the corner like this to state the convention you're using. Okay, so this convention. If you're doing lots of problems where the forces that you're considering are all acting downwards, well then you set your convention as positive as downwards, and that's often the case actually, because gravity is acting downwards, so we're considering weights often. But in structures where you're considering the up force that you're trying to use to balance these weights, then you might decide to call the up the positive. So that's up to you what convention you use. However, having set that, you must stick to it, and you need to state that convention. So having done all that, then you can do the problem. Then we realize that, okay, we're going to resolve it into its vertical. So the vertical component, you can see it's going to be like down here like this, and the horizontal component is going to be across here like this. So therefore, by convention, the forces I'm going to end up are both going to be negative. So I mustn't forget to put that in at the end, that they're both negative. And then I need a right angle triangle to do it. So I just imagine this force here has been shifted across to here to make my right angle. And this is the sort of thing we've been discussing. So I'm going to put in a line here to form the right angle triangle. And now what I'm after is the length of this side of the triangle, which gives me the vertical component of the force. And that's involved with the opposite side, so it's the hypotenuse times the sine of theta, and the horizontal component is this side, the horizontal side, which is going to be the hypotenuse times the cosine of theta, because it's adjacent to the angle. It's not always sine for the vertical and cosine for the adjacent, because it depends which angle you're given, but it's often this way round. And then we just do the calculation. So FV is going to equal 6 times the sine of 40 degrees, and FH is going to be 6 times the cosine of 40 degrees. And if you're setting this problem out, this is exactly the sort of thing you would do in an engineering situation, you know, on a structure. You've got the structure drawn out, you draw the forces, and then you do the calculation. Remember, I'm always banging on about making sure you set it out properly, so it's clear to whoever's trying to read it. Yeah. So when putting it into the calculator, check your measuring in degrees. That's the other area that you may go wrong. We've looked at angular motion, so you know now that it's likely you could be measuring angles in radians as well as degrees, so your calculator could be in the wrong mode. So always check that, and that's a very easy error to make. Here are some values, negative 3.857 newtons and negative 5.96. If we look at the values that are actually given, the force is only to one significant figure. So I would probably round that, Alan. I wouldn't say that that force is accurate to 4 significant figures. I'd round it. What's an appropriate number of significant figures in this case? 3 based on what, Daniel? You base your accuracy on the force, so this is only 1 significant figure, so we go to the same as that, or 1 more. So we can go to 2, not 3, in this case, because the force is only to one significant figure. So 3.9 and 4.6 would be appropriate. So FB negative 3.9 to two significant figures, FH negative 4.6 to two significant figures. Now if you're going to get this right, because I'm trying to relate this to an engineering situation, that's what I want. I want it rounded to an appropriate accuracy with that accuracy quoted. It's no good doing that in a way because it's too accurate and we don't know what the significance is. That would be right in many situations, but in an engineering scenario I would argue that that is what they're after. So this formula is to find the area of a trapezium. In this case, trapezium is the definition of something that's got two parallel sides, and that's indicated by the arrows, and then the other sides can be at any angle, so a trapezium. To find the area of this trapezium, we need to know the length of the two parallel sides and the vertical distance between the two. So again, we have issues around sometimes having to find this vertical height h, and so I put the dotted line in here, and you can see that it's not inconceivable that we'd need to use Pythagoras to find that vertical height. In this case, though, you're given, well, we just assume we know h, but Pythagoras often comes into questions like this too. So what we need to do now is rearrange this for b. So area is a half a plus b times h. And I think when we first looked at this formula, we might have discussed that actually the half a plus b is finding the average length of the two sides a and b. So we're sort of turning it into a rectangle. But that's where it comes from. What we need to do now, first of all, even if we don't write it like this, is to remember that finding a half of something, as we talked about right at the beginning of this course, is the same as dividing it by 2. So I could just as easily write this as a plus b times h all over 2, or think of it like that. So in other words, at this point now, I'm going to try and get b. Remember, I'm after b. Isolating b, make that the subject of the formula. I would multiply both sides by 2 to get rid of that denominator on the right hand side. So that would give me 2a equals a plus b times h. Now at this stage you might be tempted to multiply out the brackets, but if I multiply out the brackets I'm going to get a times h plus b times h, and so I'm going to have some term involving bh, which it doesn't really help because I'm after getting b on its own. So don't multiply out the brackets, divide both sides by h and get rid of that term that's outside the bracket. What this is saying is this whole bracket here is multiplied by h, so divide by h will get rid of it. So I've got that 2a over h equals a plus b, and suddenly we're almost there, because now to get rid of the b, a has been added, so take it away. Yeah, b equals 2a. So writing b on the left hand side, because that's normal for formulae, b equals 2a over h minus a, and that's our formula now to find the missing side. So to do this question, we first of all need to remember what the formula is for the area of a circle. Pi r squared. And then we need to remember that actually the diameter of a circle, which is what we're after, is 2 times the radius. So those are the two pieces of information we're going to use. So our plan to do this question is to rearrange that formula for the area so we can find the radius, and then once we've got the radius, times that by 2 to get the diameter. So rearranging this formula for the area is equal to pi times the radius squared. So at some point I'm going to have to square root to get rid of that square, but before I do that I divide by pi, get rid of the pi, so divide both sides by pi, a over pi equals r squared. Now square root both sides, So the square root of a over pi equals the radius. So that gives us a formula to find the radius of the circle. So now we can plug in the numbers. Square root of a, which we know is 12.6 over pi. And then we do that on one hit on the calculator, leave that answer in the calculator and just times it by 2. And that will give us the diameter. And then times that by 2 to get diameter equals. This gives us about 4.005 if we look at it. So if I now say, right, my answer's 4, actually if I put this equals 4, then what I'm saying, if I don't do anything else, is that it could be as high as 4.49, because I'd round that down to 4 to one significant figure, or as low as 3.5, because if it was 3.5 I'd round it up to 4 to one significant figure. So I'm emphasizing here the point I was making earlier, that you must put your accuracy and your significant figures, because it's more accurate than that. I can afford to be more accurate than that because my number I put in was to 3 significant figures, so I can go to 3 significant figures in my answer. What is this to 3 significant figures? Right, 4.01. If that had been a 4, for argument's sake, what would that have been to 3 significant figures? 4.00, good. And that's important. That is a valid answer to 3 significant figures. It's saying that it's accurate to that degree. So there's a big difference between 4 and 4.00, and that's emphasized by writing my accuracy. So in this particular case, I'm after the answer 4.01 centimeters to 3 significant figures. I put in appropriate accuracy, the unit, and then I state the accuracy that I'm giving. So by a cylinder, I mean this. And this is an example of a prism. A prism is something where the cross-sectional area, so if I cut it anywhere, the cross-sectional area would be the same. In this examples of things like this, then the volume is always the area of the end times the length. So it doesn't matter whether or not I've got this sort of shape or this sort of shape, if I can draw it. The volume is always the area of the end times the length. So it's easy to remember the formula for the volume for these things. In this particular case, all I have to do is remember that the surface area, or the area of the end of the circle, is pi r squared. So the volume is going to equal the area of the end times the length. So that's the formula for the volume of the cylinder. In this particular question, then, this last one, number 5, we've got to find the charge across the capacitor, and the formula is given by this. Here, Q equals CV. But it's this bit in blue that follows, this part, that's the actual problem. So if you are working with electronic circuits, which you will be doing, this is the question you might well be asking yourself if you're investigating a circuit. What's the voltage across this capacitor? Before I put my meter across it, I need to know, predict what the voltage is going to be, so I can see if the circuit's behaving as it should do. So I want to find the voltage across this particular capacitor with a charge of that on it. And so first step then is I need to know what's the formula that relates these 3 things. Well, in this case I'm given to it. But in reality what I'd do is I would identify that formula. I'm after a formula that involves what I want to find, the voltage and the charge in the capacitance. So Q equals CV. And then I'll rearrange the formula so that the subject is the thing that I'm after. In this case, the voltage. So divide both sides by C to get voltage. Yeah. So V equals Q over C. So now I've identified the formula and I've written it in the correct form. I then write down the things that I'm after using. What is Q? To be able to find the voltage, you need Q. It's 1.36 millicoulombs. I'd write that down. And then I'd convert it to its base unit, which it must be in. So I'd remember that 1.36 milli is times 10 to the minus 3 coulombs. So I'd literally write that down. And then I'd write down what's the capacitance. It's 650 microfarads. And so again, that needs to be in the base unit, the farad. Thank you. Yeah, minus 3. So equals 650 times 10 to the minus, micro is 6. So that's the next step. I must make sure I'm in the base units. Oh, thank you, yeah. And now plug the numbers in. So the voltage is going to be 1.36 times 10 to the minus 3 divided by 650 times 10 to the minus 6, and then I give my answer to an appropriate accuracy. So answer 2.1 volts to 2 significant figures, or 2.09 to 3. Well, that would be up to you which one you picked. They're both correct, because if we look at the numbers we put in, this is to 3 significant figures, but this really is only to 2, because the 0 at the end is not significant, unless it's stated to be significant. So I certainly would go to 2, maybe 3, definitely not 4. So 2.1 or 2.09, both fine.